Triangles. So first let's look at what congruent sides mean. If congruent angles were the same measurement, congruent sides would be the same measurement of the sides. How we mark them is with little hash marks. So you can tell that this side and this side are the same on this triangle. Or in this case, it would be this one and this one would be the same. As I'm going through each one of these today, you are going to fill in your cheat sheet with each one of these angles or triangles as we go. So triangles can be classified in two ways, by their sides and their angles. So the first place we're going to start out with is their sides. A scalene triangle, no sides are the same length. So you will notice there's no hash marks on any of these sides. Isosceles, at least two sides are the same. So you would see a hash mark here and a hash mark here. So those two sides are the same length. Equilateral, all sides are the same length. So you would find a hash mark on all three of the sides. So make sure you also draw a picture on your cheat sheet. The other way triangles are classified is by their angles. So acute triangles have three acute angles. Remember, acute is less than 90. So you will notice that these angles are all less than 90. Now this one looks like it could be 90, but since it's missing the square, it'd be less than 90. A right triangle then, you already know, has to have a right angle in it. Here's what's cool is that you know that if this is a right angle, you'll have the box. An obtuse triangle has one obtuse angle. So one of the three angles has to be bigger than 90, and here it is. So when you classify a triangle, you're looking for two things. Its angles and then its sides. So in this case, because this has the box, it's a right triangle. And because all three sides are different, there's no hash marks, it's a right scalene. All right, take a look at this one. It would be an acute, because they're all smaller than 90, isosceles. And last one, obtuse, scalene. So make sure you also, with each of your definitions that you have some sort of a picture to go with them. Then I also want you to do this, because here's the three ways we do them by their sides and the three ways we do them by their angles. So why is this important to know? One, it names each of the triangles. Two, here's the other reason. Why does the sum of the interior angles of a triangle equal 180? Well, if I take the three angles of any triangle and I just lay them down, now these aren't drawn perfectly, but if I lay them down and rotate them a little bit so they match, this angle now will fit right in here. And we've created, with the three angles of a triangle, we've created a straight line right here, right across the bottom. Here's what's also cool. If you take any angles of a triangle and you move them, watch what happens over here. So right now, this is an equilateral triangle. All three sides are the same, and I know that because all three angles are the same. And I start moving them, you will notice that the other triangles move and they coordinate each other. So if I make two almost a 90-degree angle, these two move, so it creates always 180 degrees. So we're going to use that to find the value of x to classify each. So if I have a 4 degree, an x degree, and an 80 degree, I can add them up to get 180, and I could find, using algebra, I can find out what x is. So if I look at something like this, the side opposite is its angle. So this side goes with this angle. Well, if this angle's x and these two sides are the same, then this angle over here would also be x. So I could set up an algebra problem and say x plus 106 will equal 180. Well, x plus x is 2x plus 106 equals, my pen is not working today, 180. Draw my line down, subtract 106 from both sides, and then I would need to divide by 2, and x would equal 37 degrees, which would mean this is 37, then this would be 37 degrees, and added up would be 180. These have two sides are the same, so it's an isosceles, and it's one angle bigger than 90, so it's an obtuse isosceles.